Myself, Dr. Amar Rachetti, Professor in Civil Department, IIT Mangalore. Now we go for the continuation of the curve. Curve surveying. Now, first, there's one. First, we go for arc definition and okay, okay, uh, definition of the curve. Okay, curve is designated either in the terms of degree of curvature by radius r. Okay, the degree of curvature is defined as angle subtended at the center of the curve by a chord. Okay, degree of curvature D is defined as the angle subtended at the center of the curve by a chord or a arc is specified length. A degree of curve has several slightly different uh, definition. Okay, in the degree of the curve. Okay, first we go for the arc definition. What is the arc definition? This r is equal to 360 by d into 100 by 2 pi. Okay, equal to 5729 dot 578 d divided by d feet. Okay, d is degree, r is 5730 divided by d. This is the arc definition. Okay, formula of r. Okay, then the formula for chord definition. Okay, we go for the chord definition. Now we go for the chord definition. R is equal to 50 sine 1 by 2d. Okay, so equal to R is equal to 50 d by 2 into pi by 180 equal to 50 into 3 by 360 by d into pi. That is equal to 5730 d. Okay, now we go for the metric degree of the curvature. R is equal to 1145.92 divided by d equal to 1146 divided by t meters. If the 10 meters of the arc length, R is equal to 572.958 d. Okay, these are the designations of the curve. First on arc definitions. Okay, and another one chord definitions. Okay, metric degree curvature. Okay, these are the type. Now we go for the setting out the curve. Okay, setting out the curve. First we go for the simple curve. Setting out the simple curve. Various method used for setting out the curves. Okay, first one linear method. Second one angular method. Okay, very important, linear method and angular methods. Okay, linear method, in this method only chain or tape is used, very important. Linear method already studied in survey 1 or survey 2. Okay, linear method only chain and tape is used. Okay, linear methods are used when high degree of accuracy is not required, the curve is short. Very important, when the linear method is used, when high degree of accuracy is not required, curve is short. Okay, the following are the some of the linear methods used for setting out a simple circular curve. Okay, these are the method used for a simple circular curve. One is offset method. Okay, first one is the offset from the long chord. Okay, second one is the successive bisection of the chord. Okay, third one is the offset from the tangent, perpendicular or radial. Okay, fourth one is the offset from the chord produced. These are the linear method. Okay, linear method where a chain and tape is used for simple curve. Okay, for the short curve. First is the offset from the long chord, successive bisection of the chord, offset from the tangent, perpendicular or radius, offset from the chord produced. Okay, this is the linear method. In angular method, some instrument, in this method, instruments such as theodolite is used with or without a chain. This angular method can be used for setting out the circular curve. This is also you studied in the survey. Okay, there are three methods. First one, Rankine's method of tangential deflection angle. Next one, two theodolite method. Third one, tracheometry method. Okay, these are the angular where the theodolite is used. Linear method where only tape and chain is used. Here, theodolite used with or without chain. Okay, angular method. We go for now. Now, linear method we will study one by one. Okay, linear method. First one. There are different types. First, offsets from the long chord. In this method, long chord is divided into even number of equal parts. Okay, taking the center of the long chord as a origin from the various value x, the perpendicular offsets is calculated to the curve and a curve set in field drawing the peg to the offsets. Okay. R is the radius of the curve. L is the length of the chord. 0 is the O0 is the mid ordinate. OX is the ordinate distance from the midpoint of the long chord. T1 and T2 is the tangent point. L is the length of the chord. Bisect of the long chord point D. Okay. This is the first uh, offset from the long chord. Okay. This is the figure offset above expression node x value from the either side. CD is the systematic. Okay. This is the offset from the long chord. Okay. Uh, Now we go for next one. Okay. Next one, successive bisection of the chord. Okay, successive in this method, the point of the curve located by bisecting the chords and erecting the perpendicular at the midpoint. Join T1 and T2 and bisect the long chord, erect the perpendicular CD. Okay, CD is equal to R cos theta delta by 2 equal to R1 minus cos theta delta by cos delta by 2. Okay, theta is not a delta by 2. CD is equal to R cos delta by 2 equal to R bracket 1 minus cos delta by 2. Okay, this is the formula for the long chord erective perpendicular CD. You can see the figure. This is a long chord already you studied in a survey. Okay, successive bisection of the arc. We will bisect the arc and we will join. Then finally we make the curve. Okay, join T1 C1 and T2 C2. Bisect them D1 and D2 respectively. At D1 and D2 set out the perpendicular of the CD1 and CD2. Get C1 and C2 on the curvature. Okay, C1 D1 equal to R1 minus cos delta by 4, C2 D2 equal to R1 minus cos delta by 8. Successive bisection of the chord more points may be obtained. These are the two formulas, okay, to joint T1C and T2C and bisect them at D1 and D2 respectively. At D1 and D2 set out the perpendicular offset C1 D1 and C2 D2 to get C1 and C2 of the curvature. Okay, C1 D1 equal to R1 minus cos delta by 2, C2 D2 equal to R1 minus cos delta by 8. Okay, these are the two formulas. Okay, now we go for the offset from the tangent. Okay, third one, offset from the tangent. Offset from the tangent may be calculated and set to get the required curve. The offset can be either radial or perpendicular to the tangent. Okay, radial offset. Okay, the if the center with the figure 6 1.6, if the center of the curvature O accessible from the point of the tangent, okay, in a method of curve setting the possible at the point of the distance x from T1. uh, Now it is required to find ordinate OX D, the point of C on the curvature located. Okay, these are the curvature R1 R2, there's the X, you can see the figure. 1.6. The formula here used is from the OTD, OTD, okay, OTD we get OD square, okay, OD square equal to OT square plus T1D square, okay. Now R plus OX square is R square plus S square. OX plus Rx is equal to R square, square root of R square plus X square. OX is equal to R square, square root of R square plus X square minus R. Okay, in this square root is not there. And approximate expression OX may be obtained by explaining below. Okay, OX is equal to R square plus X square square root minus R. Now OX is R 1 plus X by R whole square minus R. R comes here 1 plus X square by 2R square minus X square by 8R square plus, okay, minus R. Okay, this is the formula we are used for setting for the curve. Okay, neglecting the small quantity of the higher order, we go for OX is equal to R1 plus X square by 2R square minus R. That is equal to X square by 2R square. Okay, now perpendicular offset. If the center of the curve is not visible, perpendicular offset of tangent located front of the curve. Okay, okay. Now perpendicular, this is the figure, we can see the figure here, okay, central of the offset, okay. Now center perpendicular OX is given by the drop in the perpendicular E1 OT1, OX equal to DE T1 E1 OT minus OE square, okay, R minus R square minus X, okay, whole square root, R minus R 1 minus X square by 2 R square minus X 4 by 8 4, approximately X square by 2R, okay. From the equation 2.1 and 2.15, we clearly that equation is parabolic. The approximation circular curve replace the middle part, the mid coordinate of the curve. Okay, this method useful for small curve only. D, another one D, offset from the chord produced. Okay, offset, this method very much useful in long curve. This method point of curve is taking offset from the taken of the rear point of the curve. Thus point A and chord T1A as fixed on the O1 AA1, where A1 T1A are tangent of the simple curve. Simple B between the taking O2 B1, where A B1 is the tangent A. Okay, let T1A equal to C1 length of the first chord, AB equal to C2 length of the full chord. Delta is the definition of the T1A2, that's the definition of angle B1 B2. Okay, then we go for the chord, then the property is equal to T1 U1 curve, the circular delta T1 or T1A arc T1A1 R to delta. So delta is C1 to R O arc A1 C1 A1. Okay, now substituting what is delta 2. Okay, Q is equal to C1 C1 by 2R by C2 1 by 2R. Okay, O is equal to C1 delta 2, C2 is equal to C1 by 2R, C2 by 2R. Okay, this is 2R by C1 C2. This is the curve. We can see the curve. So this is the okay, long curve. We are dividing it in different parts. Okay, okay. Similar, we go for okay. Q3 is equal to C3 2R C1 C3 is equal to C3. O3 is CR2 got, okay, ON minus T2 square, subchord of the length is equal to ON CN 2R by CN minus 1 plus CN. Okay, now producing the setting out the curve. Okay, procedure of